Okay, so what I'd like to do is just now get from my real kind of introduction of what I think data science is and how we should think. This is like chapter 1. My dream is we're going to do chapter 1 of the book today. And, you know, what is data science? Like I said last time, I think data science is it's kind of a mix of things from exploratory data analysis and visualization. It's a mix of modeling. It's a mix of machine learning and statistics and high-performance computing and a lot of things. You know, one figure that I kind of liked that was going to describe what are different kinds of disciplines, okay? The claim would be that if you know how to hack, okay, meaning program, computer science, statistics, and a domain science, then you are doing data science, okay? The claim would be that there's programming skills involved, computing skills, there's some math and statistical skills, and in order to understand or make sense of a particular data set, you also have to know something about the domain that that data is working on, okay? One thing that computer scientists do much too much is try to ignore what the domain that they are working on, okay? They are very happy. They're saying, give me a data set, I will run it through a machine learning algorithm, and I don't have to know anything about the domain. These people do a terrible job. You have to know something about what you're building your model on. And that's kind of when you kind of have a combination of these three, that's what we'd like to think data science is. And, you know, they have these other ones. If you think about what machine learning is as a subject, this is something which is involving sort of machine learning, you know, some mix of computer science-y programming skills and machine learning algorithms, which they call as a math and statistics. Usually, if you took it traditionally, if you had a a guy who was doing research in physics, typically they knew something about physics and they knew something about math, so they could hit that zone there where they could do traditional research. And if you had a world where you didn't know any math, all you knew was a domain and you thought you could program, then you often got into trouble, okay, when you tried to analyze your data. And that's what I guess they talk about danger zone. Any questions? Okay, so we are going to be living at that world. Now, one thing that I'd like to do, again, I am a computer scientist. I am an algorithms person by training, but over the years I've worked in interdisciplinary areas with biologists and other kinds of things. And I've learned that there are cultural problems or differences between the way computer scientists think and data scientists should think, okay? And one difference, I would say, is that computer scientists usually do not really appreciate data, okay? You're brought up to appreciate algorithms. Data is stuff that is just run through a computer program. And I guess the best example of this is, I come from an algorithms world where people write papers trying to show how good their algorithm is. Sometimes they will implement their algorithm and want to show everybody how good it is. Often what they will do is construct a random data set, run their algorithm on the random data set, and publish the results or something like that. See, my algorithm took this much time on this random data set. And real scientists look at this and say, this is crazy. Why on earth would you care about the results of running something on random data that doesn't mean anything? What happens when you run a great algorithm on something meaningless? You get something meaningless, right? So the thing to recognize is that data sets are a scarce resource, okay? That when you're living in a real science, you spend most of your time getting your data set, okay? If you go to the life science building, you hang out there at midnight, there are people sitting there in labs doing horrible things to mice and test tubes and things like that to gather data, okay? And, recognize that building an interesting data set is something that requires work, okay? And I think this is something that computer scientists tend to sort of assume is given to them, okay? And part of, let's say, getting the right mindset is to realize that for many of the kinds of problems we will care about, finding the data is the hard part of the job. Any questions? Okay, good. So, what I have found was, went through and tried to look at what's the difference between computer scientists and real scientists. You know, real scientists are used to living in a messy world, okay, of the natural world, the world that was given to us by our Creator, or however else you want to think of it being. And it's got all kinds of messes, and data has error in it, and all these kinds of things. Computer scientists are used to living in virtual worlds, right? What is a virtual machine? It's a computer that we have. Is it a real computer? It's not a real computer. It's a, you know, this beautiful mathematical formulation of what a computer is supposed to do, and we are used to living in it. We are used to living in programming languages that design and do exactly what we say they're going to do. And everything is deterministic and everything is beautiful. In most of the world is a messy thing, okay? And so we have to kind of realize that when we're dealing with data, we are dealing with a messy world. Any questions about that? One way of measuring the difference is that in computer science, everything is either true or false. This is one thing that I believe, you know, basically comes down to it. You know, you're used to bits. Bits are 1 or 0. Everything that you talk about, if it's a theorem, if it's a math thing, a theorem is true or a theorem is false. In the real world, conclusions are not always so straightforward, okay? Nothing is always completely true, okay? Nothing is always completely false. And we've got to learn to live in that kind of an environment. Any questions? Okay, good. Yeah.
I have a question. So for a data scientist, the domain always changes.
Yeah.
You're not with one domain at every point of your time. So you work in one domain and then you move on to the other one.
Right.
So there is a substantial amount of time just spent in learning about the domain.
Right.
And that is what is expected out of.
Yeah, I would say that to be a useful data scientist, you have to be interested in the domain. You're probably going to move from domain to domain. There's going to be a lot of, if you're working in a company, there's going to be a lot of different projects you're going to be working on over the time. And you have an obligation to be interested in caring about what the process is that you're, you know, the thing that you're working on. So if you're going to be working in Google on the ad team or something like that, to a certain extent, as a computer software developer, you can say it's just code. Someone's going to tell me what I've got to do, and I'm going to do it, and I don't care about ads. To a certain extent, if you're analyzing ad data and trying to make conclusions about it, you should learn to care about ads. What makes an ad a good ad? What makes an ad a bad ad? What's interesting about it? You know, and so I think developing it's kind of important to develop the habit of being interested in a domain. And I think most domains are interesting, okay, if you talk to somebody about it. And that, I think, is the single most valuable skill for a data scientist. I know you want me to teach hard things and mathy things and stuff like that. But this is my belief. The good data scientist always is asking questions of people and trying to understand what's cool about the domain. The other ones are just basically programmers trying to get in, okay? And I don't think that they tend to do as good. Because usually if you don't understand the domain, it's very easy to do something that is meaningless, okay? That is either stuff that they know already, or it's stuff that is obviously wrong because you're making some assumptions that just make no sense, okay? Any questions? But still, what other things are different culturally between computer scientists and other people? When you talk to real scientists, they worry about discovering things, okay? They want to try to learn something new about the world, okay? A new factor, that this gene turns on some other gene. What gene turns this on? You know, that's a discovery process. Usually in computer science, you're building things and inventing things more than discovering it. Have I discovered anything in my life as a computer scientist? You might say, oh, well, you know, there was an algorithm out there that really was out there that no one in the world knew about, and when you found that algorithm, you discovered it. I would say I invented the algorithm. Does everybody kind of see that there's a difference? And there's differences that happen between real scientists who worry about discovering things and computer scientists. Real scientists are terrified that there's somebody else who's going to discover what they're working on first. So real scientists are paranoid people, okay, who are constantly looking over their neck and trying to stay. Because who was the first person to discover the telephone? Okay, who was the second person? doesn't matter, right? Okay, I guess that's more an invention than discovery, but I guess you get the point here. Usually when it comes to inventing, people invent different things in computer science, and there's less of a kind of a race to beat somebody, because there's always something different about what people are doing. Okay? And like I say, there's computer scientists are used to the idea that data has error, and they work around it, and they figure out what's the causes of the error, and they learn to think about that. And computer scientists generally ignore error. They'll come up with algorithms that work great if you promise them there's no error in the measurements or something like that. Okay? Because that's not the way that they think about it. But of course we have to, because we're going to be dealing with data that are measured from real processes and therefore have errors and biases and things like that. Any questions? Okay, good. The other way that I would like to break down, let's say, computer science versus data science is kind of a notion of genius versus wisdom. This is a kind of a breakdown that I like. A typical software developer, when you are hired, many of you have worked for companies for several years before coming here. You were not hired to produce ideas. You were hired to produce code, right? Someone came to you and said, we need a program that does X. You sat down and produced a program that did X. Okay? That's what a software developer does. The specifications, they do it. A data scientist is designed to produce insights. Here's a data set. What can we learn from it? Okay? And what I would say is that in general, genius and wisdom are two different things. Algorithm design is one of these subjects where there's all these clever algorithms, right? You see people who design algorithms, you say those people are geniuses, right? Because they are coming up with algorithms that are ideas seemingly out of nowhere. And when you have a flash of insight, that's what you consider to be genius. In algorithms, genius is important, okay? Sometimes in programming, genius is important. But wisdom is kind of a different thing. Wisdom, in my mind, is sort of avoiding doing stupid things. Okay, usually in general, the wise person is not the one that always does the right thing all the time. The wise person is the one who's smart enough to avoid doing really dumb things. And that's harder than it looks. That's why wisdom is a scarce resource, right? But so when we look at data science, what we're going to be looking at is we're going to be less concerned with what is the absolute best way of doing things, as trying to recognize what are terrible ways of doing things, or what are traps people can fall into, okay, that really will produce a wrong answer. Ideally we want the best possible answer to something. Maybe we'll take something that's close to the best possible answer. We don't want a wrong answer, okay? Any questions? I don't know if this is convincing or not, but these are my philosophies. And where does wisdom come from? Wisdom generally comes from experience, okay? If you've seen people make lots of mistakes before, if you're smart enough to learn from mistakes, if you've made mistakes, you hopefully learn from them, okay? So, I think wisdom is important. Wisdom comes from knowing a lot of different things, okay? If you want to, you want to be able to make connections between lots of things you know. I think that in general, the wiser person is not the genius number theorist who stays locked in their garage for 13 years proving Fermat's theorem. That person is a genius, but that person is, not necessarily the wisest person in the world, okay? They would be wiser, perhaps, okay, by having a broader base of knowledge and things like that. And so I encourage getting these kind of things. Wisdom comes from listening to other people, okay? I think that when I talk to people from other domains, I love to ask questions. I love to get a sense of what they're learning from, what they know. And that's the kind of wisdom that you want to take a look at it. Any questions? Yeah.
Based on these slides so far, where do you think the nature of a data scientist tends more towards a traditional one or more towards a computer scientist, or is it like somewhere in the middle?
Well, a data scientist, I'd like to say, is somewhere between a computer scientist, a statistician, and a real disciplinary scientist. Okay? And, a lot of these things that I'm saying about wisdom probably were traditional things that statisticians should have. Okay? Now, we also have computational skills that we care about because we're going to be interested in scale, and certain things are going to be hard on larger data sets, or harder to find data in some way or process it. But we're going to be caring about these kind of things. Any questions? Yeah.
Do data always give you an insight?
What?
Does data always give you an insight?
Does data always give you an insight? Nothing always gives you anything. Okay, so I think that's probably not true. But in general, one question is finding the right data set. An example of wisdom is finding what is the right data set for the question you care about. As opposed to, let's say, the easiest thing you can find or something like that. So finding data sets that you care about is an important issue. Okay, and again, we'll talk about these things a little bit more seriously as we go on. Any questions? Okay, this may all seem kind of nebulous, and we'll deal with it. Again, but I'm going to go through my philosophy now, and we'll then get into more concrete things. Like I say, I think that data scientists, it is good to develop curiosity. I strongly recommend everybody read a newspaper. I've said this before. That was what I said makes a good good data scientist. You should, and it's harder. In something in my day, it was easy to read a newspaper. I paid money, and it was delivered to my door every day, and therefore I had, I got to learn some things about business and some things about what's happening in the world and some things that were happening in sports and entertainment and who the Kardashians were and all of this kind of stuff. But these days, I gather it's a lot easier if you're sitting from a news feed to not really get a broad sense of what is out there, okay? And I don't know quite what the right answer is. I still read a newspaper. I still subscribe to my New York Times, and I still read it every day on paper, okay? How do people get broad news these days? Is there any way that people get broad news? What do people do? Yeah.
You go to the front page of Reddit and ignore the memes.
Front page of Reddit, okay? And how broad a thing is that?
Well, if something very, very critical happens in the world, it will be there.
Okay? Yeah.
It has to be a curated thing called the browser, which provides what he thinks are the interesting news stories, from things like the New York Review of Books, the New York Times, Discover, Aeon, that sort of thing.
Okay.
A lot of times I've seen people, mostly on Facebook, where they read the extreme things, either very sad things or really happy things happening.
See, the problem with, I guess, a lot of these targeted things is that, some algorithm is very carefully figuring out what you know and what you're interested in things that you've shown you're interested in. And so you get a lot more about what you know and less about the breadth of the world, okay? And that's kind of, I guess, what the potential danger is these days, okay? And so I like my newspaper. I encourage people to subscribe to the New York Times or read try to read it at least the front page and ideally delve down where they're interested in. But some way this is a problem you guys should solve. I recognize not everyone's going to get a physical newspaper. But any other ways that people keep track of these things? Yeah?
There's an app called InShot. So we just read the headlines of the news. So it's just 60 words.
Okay, so reading the headlines is a good thing, but it's a question of how broad. Again, if the purpose is in 2 minutes to know what is the major stories of the world, then you know what everybody else, something. But a lot of what I think is interesting when I read the New York Times, there's always these feature articles, which are not about really what the news is really a news thing that just happened. Somebody just shot somebody else. But why is there, some kind of an in-depth story about something, okay? And these are where you learn a lot of the background about the world. So
you can read something like The Atlantic. It has some.
The Atlantic. So something say The Atlantic is a magazine. The Economist, I think, is a great magazine like this.
Or anything that's not curated. Like, for example, anything that's not curated to exactly what you want.
Right. So there's a need to know something about that's not just designed for you. That's kind of my pitch here. Okay? And I'm not going to sentence anybody to doing this. But frankly, I think it's a good business to do it. And that if you read a lot over the days and it sticks in your head. How many people know what Metcalfe's Law is? Has anyone ever heard of Metcalfe's Law? Yeah. You've heard of it. But
The squared one, where the power of a network grows.
it's the squared one, okay? What was it? Was this guy trying to say why networks are good? And the claim was that networks were good because every time you add one person to the network, they can talk to everybody else, right? So if you have n people in the network, the number of possible connections grows quadratically, right? Now, if you know n things, how much smarter are you than if you know, as you know another one thing, how much smarter are you? Well, if you view it by how many connections you can make with things that you already know, learning one new thing is more powerful when you know more other new things, right? Because you can make connections between them. So I personally believe it's good to know and be interested in a lot of things. I know I'm standing on a soapbox here, and I'll stop in a minute. But this is, I think, an important lesson for computer scientists to hear, because it isn't something that happens naturally to them. Any questions? Okay, good. Okay, so the thing that a data scientist has to do, and it's going to be our main lesson for today, is learning to ask good questions, okay? If you work for a software company, you're not encouraged to ask questions. At least, this is my guess. What are you doing? The boss says, program this. Why am I doing it? Shut up. Do it, okay? Software developers, to a first extent, are not really asked. They're given a mission. They're told to do something. They do have to get the specs right and those kind of questions, and I'm not trying to be. But basically, they are living in a world where someone else is specifying what they're doing. Data scientists have to learn to be able to answer in questions like, given a data set, what might you learn from it? That's kind of, I claim, a very important question that you need to sort of learn about. If you have a data set, what might you be able to do with it? Okay? If you have customers or some people you're working with, what is it that they really want to know? Okay? Once you know what they want to know, where might you find data sets? What data sets might help you get there? Learning to ask questions about that is kind of an important exercise. And so, for the rest of the class, what I'm going to do is we're going to go through an exercise on asking questions. Okay? I'm going to talk about 4 large data sets that I am familiar with and I think can easily be explained to people that are readily available. Okay? And we're going to try to think of things we can do with it by asking questions. Okay? And try to warm up these muscles because, I think they're important muscles to be done. Okay, any questions? So the first data set I'd like to talk about is baseballreference.com. How many people here are baseball fans? I expect very few of you. Now, does this mean that you shouldn't be interested in baseball? The answer is no, because as a data scientist, you should be interested in things, right? You should be trying to get interested in things. So what is baseball? It's an American sport like cricket, is I guess what I would say to the rest of you people, right? Okay, now you guys know how many people are interested in cricket? Okay, everybody happens to be interested in cricket here, okay? So what do we know about this? This is a data set it's a website that's essentially a data set of all the records of baseball around that exist. And baseball has been played in the United States for about 150 years in a professional way. So there's a long history. So part of the data set is about individual players. And individual players, here's Babe Ruth is a very famous, he's a Sachin Tendulkar of baseball. He's what do you know about him? You know when he was born. If you look at these things, again, I'm pointing at this. But, what do you know here? When he was born, when he died, when he played. Where he's buried. Okay. Over here on the other side, right here, you know data about when he was traded. Okay. Baseball players can be traded back and forth. I've always thought this would be a good thing to be able to do with graduate students. I'd love to ship 3 or 4 graduate students off to one from Princeton maybe and get a good one back, okay, or something like that. Okay, but in baseball you can do this, okay? And so players get traded for other players. They have data about salaries here, and you can learn how much money Babe Ruth made each year, okay? That's what this other table is. There's also their records about how they actually played the game. What were their statistics during the play? What years did they play? What position did they play? How many games did they play, and how many times did they get up at bat? How many hits did they get of different types? Okay, what were their averages, and so on. And all they're based statistics about play. Okay? Any questions about that? So for every player who's ever played the game, there is now a record of what they did. Now my question is, what can you do with it? Okay, are there any questions you might ask of this data set that would be interesting? Yeah.
So what would be the performance of the player later on? We can analyze the performance of the player.
Analyze the performance of a player later on. So you want to be able to try to build a model to, in some sense, predict what they're going to do, right? That you have, in 1922, Babe Ruth hit 315, actually, according if I'm looking at my record right. And he got only 35 home runs and stuff like that. What's he going to do the year after? Okay? So maybe you could build a model to predict how good players are going to be in the future, and that would be interesting. Okay? Yeah.
Thinking like with the introduction of steroids or something, did people get better after 1975 at baseball or certain statistics?
Okay, what he's pointing out is that that there was a period of time when people discovered that by taking certain kinds of drugs, they could become better baseball players. And they tried to ban these drugs, okay, but people got good at taking them illegally. And there was a time when suddenly people started, records started being broken. Like Babe Ruth was famous for hitting 60 home runs in a season. That was unbelievable. No one had done that. And then people started taking these drugs, and suddenly everyone and their uncle was hitting 60 in a season. Okay? And the question you're saying is, how much of a difference did the drugs make? Could you figure that kind of thing out? That's actually an interesting question. I like that question, because that's now a bigger question than there's something about baseball, right? This is now a question about how much does it pay to cheat. It's a question about medical things. What are the impacts of steroids and things like that? And maybe this now is a data set which can answer a question like that. I like that kind of a question. Yeah.
What kind of teams he is most likely to join, because you know about the trading that he usually trades?
Okay, I see. You're saying what team is someone likely to join? Well, the truth is that they are owned by a team, and that's why they can be traded like a piece of meat someplace else. So they can't well, actually, it's not completely true anymore. But you're right that they're player movements, and you're trying to say some of these player movements are relatively free movements, that at certain points I'm allowed to decide what team I can play for. And maybe, can I say something? Do players choose to go to teams that are winning teams or losing teams? Winning teams are probably more fun to play for. Maybe losing teams are more desperate and will pay more money, right? And so what does this say about that? And maybe we could learn something about that. Yes?
As simple as ranking the players based on a number of different parameters based on this score data.
Can we rank the players to figure out who's the best player? So in fact, many people would say Babe Ruth was the best player ever, but maybe somebody...
In certain parameters, not in others.
Can we determine something about how good these people are? Ranking them to highlight who were the best, who were the top 100 baseball players ever. Yes?
Growth trajectories of salaries of a player over time, like say star players versus the bid players. Like for example, Babe Ruth would have earned a lot of salary because he was one of the stars, right? So his growth in salary would have been a lot more exponential as compared to players who were not as probably good as him or famous as him.
Right.
So you can probably track growth trajectories of players over their careers.
Okay, so there's some question of how, when is it that people make their money over their careers? Is it that they are poor at the beginning, and if they stay around long enough, they're going to make it, you get seniority and you start earning the money when you're older, okay? Or is it that, so we agree there's lots of things you could learn from the salaries. I think the salaries become an interesting question. There are a lot of interesting questions you can ask around salaries, okay, yeah?
So just building on that, baseball is not a game that I fully understand, but like on the transfer market, how accurately is a player valued compared to how good he is, and then can we get like...
So this is very good. Players get traded. Again, I'm ready to ship off 3 graduate students for 1 from Princeton, right? Now, is this a good trade or a bad trade? Is it the case that in fact, Stony Brook students are as good as Princeton students, and that these guys would be, if I ship 3 of them off, I'd be getting, 1. So the question of, can you analyze how successful trades are, okay? in general, when teams make these trades, are they generally balanced trades based on either the past or the future? Or is it the case
how
that...
accurately they were valued? Because earlier, I mean, now I'm sure they have computers to, and like statistics to value like how much a player would be worth. But back then, I'm sure the scouts just on intuition or some gut feeling.
So the question of, are people being paid what they're worth? That's, I guess, a question really that kind of would be interesting. You know, yeah, let's go back.
So, if you're an analyst on the past data, like if there were any general performance spikes due to maybe some new technique
Like taking drugs or something like that. That's the kind of argument that you're making. Yes, let's try this one.
Apart from like the fundamental thing for which they were known, like if somebody is good at batting, if they've improved in a year on some other metric and they have increased their value as a player, like so some sort of a secondary ranking of who has improved in a
So
year.
who's improved? Can you figure out who's getting better? So let's say if I want to trade, if I see evidence of a player is getting better, maybe they're undervalued historically. That might be interesting. Yes.
You could just do it like straight money ball style and look at how many wins over an average player at their position. You think?
You know, again, compare. Can I analyze this to get a sense of who's the best player at each position? Is what you're saying. Okay, so there's a lot of these things. Let's go. So that's a good start. Let me see what questions I came up with when I was looking at it. And some of these things we've already discussed. How do we measure individual players' skills and value? How fair are trades work out? That I think we looked at it. What's the trajectory of people's performance as they get older? In other words, I mean, in general, is it the case that, you know, that is it a, well, I mean, if you look at a player over their lifespan, let's take a look at, you know, my performance as a professor over my lifespan. This is me being when I was 20. I will hopefully be a professor till I'm 74 years old. Okay? And you could imagine a world where my performance, as I rapidly learned how to be a professor, maybe it's the case that you learn to be you learn your job and then you keep that level of performance the rest of your life. But if you're an athlete, probably what happens is at some point you rapidly get up to your skill level, and then at some point your skills start to decay, right? You get old and worn down, right? Okay, so what does the trajectory of this look like? Okay.
Same thing happens for professors.
Professors presumably also, okay, they won't admit it, but it is also probably true that there is a reason why universities encourage old professors to retire. Let's put it that way, and that's what you're saying here. Okay, but what's interesting, I guess, is studying something like this. It's hard to study this on a professor basis because I don't know maybe what the right data set is. But this is a data set to study how performance changes over time in a discipline. Okay, and that's an interesting thing. Okay, any questions? But there's also all kinds of other things that you can answer from this, if you're clever, that are outside baseball. And these are where I like the idea of thinking about when our data sets are interesting, when you can repurpose them to effectively answer interesting questions that it might not have been obvious why you were dealing with it. So one study that I really liked once that people did was, do left-handed people live as long as right-handed people? Okay? Now, how could you do this kind of a study? Okay? You can imagine there's lots of records of when people were born and when people died. But are there records of who was left-handed or who was right-handed? And that's something that, you know, it's not obvious that, maybe your doctor recorded this someplace, but how do you know that? Well, it turns out that the people who kept the baseball records, we know that Babe Ruth batted left and threw left, right? So in fact, you could do a study. Okay, and people did looking at all of the 15,000 dead players who had played Major League Baseball. Okay, do lefties live less or more or the same as right-handed people? And they found that lefties live less. Okay, and I'm lefty, so this is a problem. But but this now is an interesting kind of a question. This is the kind of study that I like to see. Someone took a data set and did it a different way. What other things are interesting? How often do people return to live where they were born? Yeah?
Professor, the first question, don't we run the risk of running into external factors? For example, we are looking at sports data, right? So many players might run into injuries. So, like external factors might also be.
So there are questions that start to get into questions of sampling biases and things like that. Are the lifespans of baseball players representative to that of the lifespans of other people? Okay? Probably it doesn't say a lot about women, for example, because there have been no major league women who've played Major League Baseball. Okay? So there are sampling issues here. Okay? And being aware of this is the kind of thing that is why I say being wise and starting to know about broader things, thinking about what the data set means, okay, is a question of wisdom, right? Now, it's very easy to say, oh, I can write a program to count how often lefties, the average age of lefties versus the average age of righties. That's a computer science-y question. But the question of, is this representative of another, you know, a more general population? That's now an interesting question, okay? And that requires knowing more about the world and thinking about it. Is there a more appropriate data set for it? These are interesting things to think about, and are the kind of things we have to be aware of. Any questions? Okay. You know, similarly, because they have the height and weight of these people, you can see our baseball players, our athletes getting taller or in better shape than they used to be. You know, that's an interesting question. They're earning a lot more money now. My guess is it's maybe more competitive, you know, and so, you know, you don't have the... But again, that's the kind of thing you can study. Any questions about this? I like something about how often do people return to where they're born. You know, someone like me, I was raised someplace. I went off to, you know, another place to go and go to university, and then am I, when I get old, and going to retire to where I grew up or not? How often does this happen? If you have people here who, you know, where they were born and where they died, you can start to ask these kind of questions. Any questions? So I claim that there's interesting things you can learn from this that have nothing to do with baseball if you know how to ask questions. Any questions? Yes?
In that example you just mentioned, as far as people returning back to where they were born, you don't even necessarily, you're going to have lots of errors in that data, because some people could be born in one place just because of a good hospital, and then a week later go like a state away, and then live there.
Okay, so there are questions of, is this the best data set for doing this, or would maybe a better data set would be knowing things about birth, you know, there are birth certificates and death certificates granted people. But again, the question for now is, can we think of things to do with this? And again, we can then just quibble of how good this is or how bad it is for the particular question, whether there's a better data set. In general, the data set you have is a good data set until you have a better one. Is that clear? And once you have a better one, then it's not as good. Any questions? Yes?
About the first question, so you are a lefty and I'm a lefty, but then the difference is that you're from a developed country, I'm from a developing country. So those factors also come in.
So the question of whether this applies to me or you is an interesting question. There's some belief that for what it's worth for the lefties, this is supposed to be more, maybe this is not a problem anymore. The presumption was that if you were a person working farm machinery, okay, for, you know, back 100 years ago when you stopped playing baseball, you became a farmer or you worked in a factory or something like that. And there you were probably working on equipment that was designed for the other hand. And maybe lefties fell out of tractors more often because the tractors were designed for righties, okay? And so there is a question of to what extent is it relevant or not. But these become intelligent questions once you have got an intelligent data set that you've analyzed. What are the results? What do they mean? This is now where people are talking at a high level to think about it, okay? Any questions? Okay, as opposed to my cousin was a lefty and he had a heart attack at 20 or something like that, okay? Any questions? Okay, let's look at another data set here and to see if we can ask intelligent questions about it. The data set that here is IMDb, which I imagine many of you were familiar with. IMDb is a database. You can actually download the whole thing, or at least a sizable fraction of the whole thing, which will tell you for every movie that has ever been made, okay? It'll tell you all kinds of information about the movie. What do you know about the movie? Oh, you do get my, you see my mouse, right? So that's good. Okay, so what do we know about the movie? It's a Wonderful Life, which is a good movie. We know when it was made. We know how long it is. We know what categories it was in. We know what other people who watched the movie thought of it. Okay, what were the ratings that they gave it? We know a little bit of story of what it's about. We know who the people involved were. Who were the stars? Who was the director? How much money did it make? Stuff like that. Okay, if we know that for every single movie ever made. Okay, we also know data about all the actors. For any particular actor, we'll know when they were born, when they died, what movies were they in, what awards did they win. For any movie, we'll know all the actors that were in it. These were all the actors that were in It's a Wonderful Life. Okay? Any questions? So based on this is IMDb. What can you do with IMDb? Okay? Yes?
Well, people say that like Vietnam was an unpopular war, but World War II was like a popular war. The American had an image. So like, were more movies made about Vietnam than World War II? Did those movies gross more on the whole than movies made of Vietnam? Can you gauge?
Okay. So let's think about that. Is this a good data set for that or a bad data set? Well, what can we say about it? Can you tell, how would you tell which movies were about Vietnam War and which were about World War II?
Well,
Maybe from the title, but it's hard to tell me Deer Hunter, the Deer Hunter. What war was the Deer Hunter about? Maybe in the description it might say a World War II veteran Audie Murphy did this, okay? Or, so maybe you'll know that. But it's less clear to me how well you know that. But yeah, there were some other ones. What was yours? Yeah. So it's something about how does the interest in genres of movies change over time, right? There was a time when people watched westerns in the United States, the cowboy and Indian type movies. Not your kind of Indian, but the cowboy movies, okay? Those were those were very popular probably from like about the 40s to probably about the 50s or so. They're a lot less popular now, right? So we could imagine charting the the genres. When do genres come in and when do they fade? Yes.
Try to look at what amount of time in between, like recently remakes of movies have become very popular.
So this is an interesting question. So the question is, how has the imagination decreased as a function of time? You can imagine that at the beginning of time, people were making movies about new things. Everyone had to come up with when every movie was a new idea. I know, let's make a movie about, in this case, this angel comes down and let's Jimmy Stewart see what his life is like if he died or something like if he didn't exist. Okay. Now you can imagine remakes are often done. You'll say, oh, to make a movie today, I'll look for a movie that was popular a certain number of years ago and maybe redo it. If it was successful then, maybe it'll be successful now. Are there more remakes being made than there used to be? And is the gap of time between when it's polite to remake a movie, has that shrunk? My instinct is that probably there are more remakes, and probably the fear of doing a remake from something that was only a couple years old has dissipated, right? And this would be an interesting way to measure as a proxy, what's the level of originality in these things. I like that one. Yeah.
We can look at the revenue of the movie and then look at its ratings after a few years to understand how heavily it was promoted before its release.
So one question is, you say it may be a question of how it was promoted. What I'm wondering here about is, are you saying the ratings of the movie in terms of how people liked it versus how much money it actually grossed?
There could be movies which receive a lot of revenue but could turn out to be bad movies after.
Yeah, so there's a question, my daughter made me go to this movie that was a terrible movie, okay, but it made an awful lot of money, right? So is it true that better movies make more money than worse movies? Okay, that seems like a perfectly interesting question to analyze, and you potentially have data for this kind of thing. Anything? Yes.
Correlating the date of release versus the money made at the box office. In the sense, so in India at least, a lot of movies are released at certain times because at these times there are holidays and people end up going and watching movies.
Right.
So there is there is a correlation between when a movie is released and the
right. So in the United States, the big blockbusters tend to be on Christmas, or you know, they try to release them on a day when people are off of work, so they can go and spend their time watching. So yeah. So this question's up to that kind of thing. Yeah.
So let's say we have a movie around baseball. So we can do an analysis that how much it affects the popularity of baseball for a certain number of years. Or
so you want to say now you're interested in how much does the release of a movie affect the popularity of this thing? So for example, there was a movie that was released recently about the Indian mathematician Ramanujan, right? Does everybody remember that? Okay, and so you can kind of imagine, I knew whom Ramanujan was, but you imagine most people in the world did. A lot of people, you know, on the street didn't know. How much of a pop does his reputation get? You probably don't get that exclusively in this data set, because I don't know how you measure how popular Ramanujan was 2 years after the movie. Certainly not within this data set, but maybe if you had some other things. Let's what do I want to do? Let's say you. So how much does the movie poster have on it? So this is interesting. Can you look at a movie poster? Here we got a movie poster over here. Can you look at a movie poster and tell something about how good the movie is? Okay? In principle, a movie poster is a form of advertising. Is that right? And you know, if you're Google, we said a few minutes ago, you cared about how good, you know, you care about how advertising works. Can you learn anything about how successful, what makes a good ad or a bad ad from looking at movie posters? That's kind of maybe what you're sort of saying. You'll know how successful the product was. You'll know what the poster was that advertised it. Could you correlate these things? And for the record, actually, I was screwing around with somebody. I was on sabbatical at Yahoo this year, and it was an image processing guy who I was talking with, and we played with this a little bit, actually. But we did actually take a look at movie posters, and he built some classifier that would try to predict, you know, the gross of a movie or the quality of a movie by looking at the poster. Can you predict the genre of the movie by looking at the poster? The genre is relatively, you know, you can do it to a certain extent. Okay, some of these other things are harder. But yeah, that's an interesting question. Okay, let's try just a couple more. You
can also have an understanding of what topics a particular demographic is more interested to talk about, to learn about. For example, if a movie on science and fiction is running more in a particular country, or we can understand that there are more intellectuals, more educated people there.
So can we learn something about what topics are interesting to a society? Maybe how does that change? So the claim would be that if you had some planet, some country where everyone's watching films about Ramanujan and Einstein, that you're claiming is a smarter thing than the country where they're watching about superheroes. Okay? Maybe. Okay. Let's see a couple of other ones. Who else haven't I gotten? You. Yeah, you. So the question, so one question that's good is, how do actors and actresses compare? Okay, this is actually interesting. There's gender issues here. Are actors and actresses treated similarly in movies? You're mentioning here about salaries. I'm not sure whether or not I got the salary here for what these people make. But it would be interesting to compare salaries. But there's other kind of gender things you can tell. Okay? Any other particular ideas about gender things you would want to tell otherwise? Okay. Yeah.
Female male participation, how it changes, how many females used to participate in own movies, and how many.
You know, again, are the same number of, what's the male to female ratio in staffs? That might be one thing you could tell. Any other ideas? Let's say you, yeah. Okay, so there's a question of how much do stars matter? Okay, this is, I guess, your question. That suppose I am trying to cast a movie. Okay, I would like Brad Pitt in my movie. Now, Brad Pitt will say, that's great, but you got to pay me. Okay, now, you know, I could hire Brad Pitt. You could hire me. I'd work a lot less, for a lot less, right? Is it worth it for them to pay Brad Pitt, right? And the question of, are stars worth the salary that they're being made? Maybe stars are underpaid because the amount that they add to a movie gross may be wildly more than this. Maybe stars are overpaid. Okay? This is a kind of an interesting question. Yes?
So, I just thought of it now. Like, if you just look at the cast, can you predict what genre of movie is it? Like, if Harvey Keitel is in it, is it a Martin Scorsese movie? Or
Okay, so you might want to look at a cast and see if you can predict the genre from the cast, right? Like, you know, if you see Harvey Keitel, it's probably not a musical or something like that, right? Okay. Anyone else we really need to care about? Yeah, tell you.
Since we have debates around the biographies of the actors, we can ask questions like what would be the life expectancy of people who are residing in fields and areas like that.
Okay, so there's things about the lifespan of these people, okay? So what were the kind of questions that I asked? One of the ones that I asked was kind of like this kind of thing. So the bottom question here, do stars live longer or shorter lives than bit players? I mean, the average, you know, my vision is that if you're a Hollywood star, you know, you're supposed to live fast, die young, and leave a good-looking corpse type of thing. Is it true that do stars or motion picture actors, do they live longer than the public or not? Do they live less short? Do the bit players live longer than the stars? These become kind of interesting things, okay? What other things are interesting? We talked about gender issues. One interesting gender issue that is true that you could probably tell from this data is there's certain biases in casting movies about the age of actors and actresses, okay? It is well known that, you know, you have old men in movies. Their wife in the movie is always incredibly young, right? Harrison Ford is still in the movies. You know, whenever he makes a movie, his wife is 20 years old or something like this. Okay? The question of to what extent are there differences in the age distributions of actors and actresses? Seems like that tells us, is it the case that this spread is increasing or decreasing? Okay? Maybe my sense was that at one point in time, maybe in the 30s, people were cast with people of the appropriate age, okay? And this is probably not true anymore, okay? How has this shifted? There should be enough data in this to try to tell. Any questions? Yeah?
Because we have the release date for every country we have, we can see what kind of genre is not popular in some kind of countries, say in China, and the supernatural movie is not allowed to come in.
I see. So the claim would be that if you knew something about the countries, again, if this website or some other ones captured all the data about movies from different countries, again, how do different countries have different topics? You're saying that ghost movies are not allowed in China or something like that. Okay, so that would be an interesting thing that might fall out of the data. One other thing that I would say that is another thing people do with IMDb data is you can build a social network on the actors and actresses. Okay, you can say every vertex in the graph is a person, and there's an edge between any two people who are in the same movie. Okay, that's a natural way to think about building a network on it. And there's all kinds of interesting questions you can ask on that. Okay, the fun questions are related to this game called like the 6 Degrees of Kevin Bacon. And how many people have heard of this one? You know, there's a question of how many movies apart would you have to be till you played in a movie with someone who played in a movie with Kevin Bacon. And the claim seems to be that Kevin Bacon is this very central figure, that he's been in so many movies with so many different kinds of people that, you know, he knows a large number of people, and people who know those people. The question of studying these network properties, it should be clear that with a data like this, you now have a social network, and there's things you can start to build with this kind of thing. Yeah?
You have the same idea for mathematical research papers in Paul Erdos, your
Yeah, so you've heard of, those of you who have heard about Erdős, how many people have heard of Erdős numbers? So there was a very famous mathematician named Paul Erdős who had a strange life. His life was he didn't have a home. Okay, he went from math department, lived from math department to math department, and wrote papers with lots of people. And it got to be kind of a game where if you had written a paper with Paul Erdős, you said your Erdős number was 1. If you were Paul Erdős, your Erdős number was 0. Okay, so not too many people had Erdős number 0, but a lot of people, like about 1,500, had Erdős number 1. If you wrote a paper with someone whose Erdős number was 1, you had an Erdős number of 2. And it got to be, how far were you from him? My Erdős number is 2, by the way. And so anyone who writes a paper with me gets an Erdős number of 3, which is pretty good. You can't get an Erdős number of 1 now because Erdős is dead. Okay, so I'm about the best you can do at this point. Okay, any questions? Okay. Okay, I think we have this kind of an idea. But there's all kinds of things you might do with that network. You know, one network would be like, for example, how many movie roles are the results of, you know, do actors, when they cast a movie, cast everybody or they only cast their friends? And it might very well be that, that a lot of these decisions are made because of communities, and that would be interesting to figure out. So I claim that there are lots of different things you can learn about that are not obviously things just related to movies, if you think intelligently about data sets, expansively about it. Any questions? Okay. Another data set that I like, that I did mention in the introductory lecture, had something called Google Ngrams. Google scans books, okay? Google does a lot of things. Among other things, Google's have scanned something like 15% of all the books that have ever been published in the history of the world, okay? And this gives you quite an interesting resource in many ways, because one thing you could look at is how often are words being used, okay, as a function of time. Every book, they know when the book was published, okay? And what they've done is they've scanned all these books, they've read all the text, and they've tabulated for every short phrase, meaning a phrase of up to 5 words, how many books has it appeared in, okay? And for any book that has appeared, any phrase that has appeared more than 40 times in recorded history, in books, they will give you an annual time series of how often that thing has been mentioned. So if you want to, again, I was mentioning, you want to see how often Stephen Skiena has been mentioned in time. There was no Stephen Skeenas up until about the mid-'80s. Then, you know, as I started getting a couple of publications, it went up. There was a little bit more Skiena-ness, and then there was a book, and, you know, eventually I will die, and people will stop reading about me, and that will go, Skiena-ness will go down to nothing again, right? So you can imagine that there are these time series you can build about for the last, certainly the last 200 years, and it's thinner past the last, beyond 200 years. How often was every single short phrase used? This is measuring the frequency of Frankenstein, Albert Einstein, and Sherlock Holmes as a function of time. And what does it look like? I mean, Frankenstein goes back the longest because he was the first one that there were books written about. Frankenstein was back around 1800 or so, Mary Shelley. Sherlock Holmes didn't get invented until like the 1880s. Einstein didn't get invented till about 1905 or so. But what do we see here? You know, it's clear that something happened to Frankenstein, right? Frankenstein at one point became, about the mid-60s to 70s, kind of became used a lot more relative to what it had been before. Maybe people started using Frankenstein as a metaphor for things, right? Frankenfoods and all these kind of things. And so you can measure these kind of trends by using this thing. So figure for every phrase, short phrase, we can know for every year for the last 200 years how often it was used. What can you do with that? Okay, any questions you can imagine answering if you have this kind of data about word/phrase frequency over time. Yeah.
We could try to analyze how long it takes for something to catch. I mean, when someone, Shakespeare introduced a lot of phrases, and now it's like used by everyone. So we could do like how long does it take after first published to catch on to the general public?
Okay, so there are questions of how quickly is it, what is the shape of adoptions of terms. We could imagine there's lots of different shapes that the frequency of adoption might be. It may be that someone invents a new phrase and it takes a while to disseminate to the population and people slowly learn it, and then as many people know it and they use it, and it kind of sits like this, that there's a learning process and then it's been adopted. It could be that it's more like a fad thing, that a lot of terms go and suddenly, boom, somebody invents it and within a year everybody knows about it, and a year later they're talking about other things, okay? How fast do these things grow or decay? In principle, this is the kind of thing you can tell. Yeah?
I mean, I was thinking just about like racism and things like that. Like, can you tell if after the Civil Rights Act or something that pejorative uses of certain words went down and you know,
So this is a good question, that there are pejorative terms that we're not going to use in here, that are, you know, that certain groups have been called over the years. And these things, you know, when did they become popular? When did they stop becoming popular? This becomes the kind of a thing you can study at. Are people using less pejorative language than they used to? This is potentially something you can tell about. Are we politer than we used to be in books? Are we worse in books? Okay. Yeah?
Similar, but less to do with pejorative terms, more with just general language, where the language has become less complex. Because books that are published recently, I mean, I find that their sentences are shorter, they use simpler words.
Okay, so there's a question of what is the vocabulary usage and structure usage that people are doing. Now, these are only short phrases. These are phrases only of length up to 5 words. So I can't tell you whether sentences are getting more complicated. But I probably can tell you about our certain, you know, phrases, let's say, involving rarer words becoming more popular. I can well, more or less popular. This is now something that you can potentially do.
But how would we like get like Sherlock Holmes? We're talking about like 5 words, right? Like how is it?
Up to 5. They do it for words of 1 to up to any short phrase of length 1 to 5 words. You can get this kind of data for. Okay? Yeah.
We can probably track the usage of slang over time. Like for the longest time, people did not use slang in publications, and in the recent time, it's grown up a lot. So like you can use it for slang, you can use it for cursing.
So again, are there I would say curse words, or would be a good example. Okay, my sense is there's a lot more cussing going on in print or than there used to be. Is this true or is this not true? That would be interesting to know.
Use of different words to describe the same thing, describing something using different words over time.
Okay, so there's different questions of. There seem to be a lot of applications of the form. Which words are being used over time? Okay, and so we agree that's a class of things. Yeah.
Whether a particular field is picking up or not, you can probably figure out that.
Are there particular fields going up? So it's certainly true that if you wanted to, like, remember back to my first slide from last time, I saw that data processing was a hot field in the 50s, and this disappeared. None of you want jobs in data processing, right? And the question of when do scientific disciplines emerge? When do they achieve more popularity? When do they start to fade? Okay? This is the kind of thing that one could learn about. It's a little different than language use. This is more topic use, right? And we can look at trends in topics. Any questions? Let me see. What were my questions? We're starting. I think we have about 10 minutes or so. So what were my questions here? Okay? I was interested in how much people curse over time. That I think is interesting. How often do new words emerge? Are more words emerging now than used to emerge? This would be one thing that's kind of interesting. Okay? You know, what is the lifespan of technologies? So, you know, if you think about it, if you looked at what the time series for radio was, Radio was something that people emerged in the 1920s, was a really great thing, and then when they invented television, it probably became less important, right? And television probably came out here. And now that they've invented the internet, maybe you don't watch television anymore. Now, and then so you could kind of imagine tracking technologies and things like that. One other one that someone told me that they were studying here, which I thought was interesting, there was a guy in the linguistics department who wanted to study the history of spelling, okay? And when is it that people start, are there more spelling errors in printed books now than there used to be or not? What has been the history of spelling? And, my guess is these days, probably there's very few spelling errors because people use spell checkers, okay? They don't know how to spell. But on the other hand, that it's probably true that at times, in the early history, there was probably more variation in spelling than there is now. And charting these things and seeing how that works, that sounds like an interesting thing. Any questions? Okay, my last data set, just to go and wrap it up, I guess there's a data set that has been made available by the New York City on basically every taxi ride that is taken in the city of New York. So when you go into the city, again, it's Labor Day weekend, have a good time, go into the city, take a taxi, okay? And when you do there's a meter, and they're going to record when you got into the taxi, where you got off. If you pay with your credit card, your fee, the meter calculates how much you owe, okay? It'll record all these kinds of things like who the driver was, at least as a hash code. What was the taxi that you were in? When was the pickup? Where did it go? What were the coordinates of where it went, where it came from? How far was it? How long did it take to go? And you can do this. They have this for roughly, I think we have like 80 million trips that people had taken. But you figure people have taken, a lot of people, there's a lot of days in a year. They've been doing this for several years. There are a lot of taxis out there. You can imagine all this kind of stuff. What could you do with this kind of taxi data? Okay, a lot of people. Let's say, what do I like? Let's see, any people I don't know, you, let's see. Yeah, you. Go. So one question is, if you are a taxi driver, can you analyze this and figure out where are there likely to be a lot of people wanting rides who are lucrative rides and start circling like a shark in the hope that you're going to get one of these guys? Yeah.
If I wanted to open like a bar or a nightclub, I could see where cabs with usually multiple people were getting dropped off on weekends between like 10.
So one question is, you might be interested in what spots are people getting dropped off at. You're saying for placing a bar.
Yeah.
It might be a way of measuring how popular a bar is in some sense. That if I see a spot on this block that is unusually rich with people getting dropped off, why is that? Okay? And that might tell me something about how the city operates. Yeah.
So I want to see how frequent people are now using cab after the Uber.
Okay, right. So during this time, somebody invented Uber. And so what has happened to the taxi market since Uber? This is a terrific thing to tell. Okay? Are the number of rides going up or down? Is it that people are using Uber for long rides but not for short rides? Okay, maybe if so, then maybe the longer rides are there's fewer long trips than there were before, but more short trips. That might be an interesting thing to study. What other things do we have here? Yeah. Okay, so there's a question of, do drivers are there courteous, efficient drivers, okay, who people like, who get more tips? In principle, you pay a tip, you should be able to know, do certain drivers get more tips than other drivers? Okay, that seems like an interesting question. Yeah. So you can learn something about the traffic flow in the city. Okay, you'll know that where people are coming from and where they're going. You also know how long it took them to get there. So you know when is there congestion and where is there congestion. This is something that kind of falls out of this kind of thing. And maybe you could use this to design a new city, okay? More likely you would use it to figure out where do I move so I don't have the congestion, okay? But we agree that this kind of stuff, properties of how transportation work in the city are encoded in here. Any questions? Any other ideas? Yeah?
This actually the GPS doesn't get the information always correctly. There's always an error. So sometimes the GPS goes off. Most of the when people are like taxi want to go to another route, like what do you call it, an emergency situations or something, like a hijack or something, you can keep track of it. If they divert the route and again come to a GPS.
Okay.
This was actually a project I have done.
Wait, you mean to try to figure out when the taxi is not going on the route it should be going? Okay, so this is a problem possibly if, you know, some bad guy holds you up and says, you know, we're going to kidnap you. Now they're going to, you can know if the bad guy is doing that. Another possibly more likely is that the drivers in New York, they get paid by how far the drive is. And they love picking up tourists at the airport. Oh, you've never been to New York? So did you realize that the shortest way to get to the city is through Stony Brook? You know, that's, you know. And so that would be maybe the kind of question. The questions about which drivers are there that, quote unquote, take their passengers for a ride. That would be kind of the thing. It might be interesting. Yes?
Yeah, how are the modes of payments over time? People used to pay through cash in the first place. We can vary the modes of payment.
Okay, so there's a question which is actually interesting. Do people pay by cash or credit card? Okay, and that I believe is recorded here. Okay, and so you might learn something about that. Okay, yeah, let's say there's two more, and then I'm going to wrap this up.
So we have the number of passengers here. So maybe I don't know. We can make an assumption that we have like when we have like 4 people or something, it could be like a family or something. I don't know.
So if you know something about the number of passengers,